Okay, our next speaker is no stranger to having to deal with more than a dozen countries and partnerships internally, but more importantly, a long-standing partnership with NASA going back to the 60s on many, many missions. It's Andreas Teichmann. He's the head of the European Space Agency, ESA's Washington office, where fundamentally he's responsible for both partnerships with the U.S. Space Agency and Canada. Prior to that, he was in the Office of Human Spaceflight over at ESTEC in the Netherlands, and he was responsible in particular for the commercial utilization of the space station and also for education programs. He holds a doctorate in control systems, and he has a long-term career in ESA and time with the German Space Agency also prior to coming to ESA. Andreas?
Thank you, Joe. Thank you, the organizers, to having me here. And thank you for this great topic. It is a pleasure to talk about partnership and cooperation. The partnership between the US and Europe does certainly matter, at least to us. I hope also to the US. It has a long tradition. And it was encouraging that the national space policy was putting such an emphasis on even enlarging international cooperation in the further pursuit of space activities in the US. The second reason why it is a pleasure to talk about partnership and cooperation for an ESA staff member is that I believe ESA almost symbolizes international cooperation. We are an international intergovernmental organization representing 18 member states, soon 19 member states. And we experience that cooperation is very rewarding, of course, admittedly also often very complex and difficult. Making 18 member states setting common objectives to pool their resources and to let their industry working together is not always something which is easily arranged, but it works. And I can say that cooperation is not only a tool for us to achieve objectives in space. We always developed a culture of cooperation. And if there's anything as that ESA can teach the space world, then I believe it is the experience in cooperation that we embody. To give you a few data about ESA, because ESA might not be so well aware and known to the audience, we have a budget of 4 billion euros. It's approximately $6 billion. We develop science missions, studying the solar system, the universe, the Earth, the environment. We perform research under microgravity. We also develop application missions, weather forecasting, telecommunication, Earth observation, and navigation. And we develop the launchers which are necessary to provide us access to space. This year we call the year of the launchers for ESA because we will have 2 new launchers in operation this year. The first launch of the Soyuz launcher, which will be launched from Soyuz, from Kourou, our spaceport, and the first launch of Vega, our small launcher, also this year. Soyuz will, by the way, launch the first 2 operational Galileo satellites of our satellite navigation system. So we now have a complete set of a launcher family, from large launcher Ariane, medium-sized launcher Soyuz, and the small launcher Vega. Inside Europe, we have a cooperation that matters, that is with the European Union of 27 countries. So together with Norway and Switzerland, which are not members of the European Union but members of ESA, we have in total 29 countries in Europe which are supporting space affairs and cooperating in space. These countries approved a European space policy in 2007, and 2 flagship programs, most known are Galileo and GMES. Galileo is a satellite navigation system, where the 2 first operational satellites will be launched this year, and GMES, which stands for Global Monitoring for Environment and Security. It should be it also even was new to me that the European Union is meanwhile this largest single contributor to ESA programs, not France or Germany, which you might believe. It is now the European Union which funds about 20% or contributes about 20% of our budget, and is in so far a really strategic and important partner who matters. And not only because of this significant funding to our activities, but also because the European Union is in charge of defining policies like agriculture, transportation, security, environment, which define needs for space and which use space as a tool. So it is not only a funder, but also a federator of demands. So a very important strategic partnership between ESA and the European Union. Outside Europe, ESA is practically cooperating with every spacefaring nation in the world. Obviously with the United States, which forms the technical culture of our space activities, but also with Russia in science, in space, in the ISS program and in launchers, but also with Japan, China in science, India or Canada. The cooperation with the US has certainly the longest tradition. It began in the 50s when the US invited European scientists to fly experiments on US satellites. And many cooperative science activities and programs followed: SOHO, Ulysses, Hubble Space Telescope, only to mention a few. A good example is the cooperation with NASA in the Cassini-Huygens missions, where ESA's part, the Huygens mission, would not have been possible without the NASA part and vice versa. So these kind of interdependencies are certainly the most important and cooperations that really matter. The second field of a long tradition in our bilateral cooperation is human spaceflight. It started with Space Lab missions in the 1970s to 1990s, and then of course in the International Space Station program, where Europe built the largest part of the pressurized volume, and is proud to have soon 2 European astronauts together in space, and currently having the ATV, the automated transfer vehicle, docked to the space station. A third area of long tradition in cooperation between the US and Europe is in meteorology, what Charles Baker already mentioned before, where NOAA and EUMETSAT since long cooperate. But beyond those established fields, we were also able, in particular between ESA and NASA, to widen the scope of cooperation. In 2009, ESA and NASA signed an MOU concerning the cooperation in the field of space transportation. It defines terms and conditions for the exchange of technical information and cooperation in specific areas of common interest in the area of space transportation, which may be getting more ground now also when we look into the exploration program. Also in 2009, ESA and NASA agreed on the roadmap to increase their cooperation and coordination in Earth observation, which was surprisingly little scope in the past, and we found out that it is useful and reasonable to extend this area, which is already existing, as I said, on the more operational side between NOAA and EUMETSAT. And since a few years, the European Union, so not so much ESA, but the European Union and the Department of State and Department of Defense are intensifying their discussions and cooperation in the field of security space, namely space situational awareness. This demonstrates that our cooperation is close and evolving, but so far so good. There are certainly also problem areas. And yesterday in the panel, afternoon panel, and also what I understand today, we saw that in the areas of most promising future cooperation, science, Earth observation and exploration, there are some complications on the horizon. Space science, that was addressed yesterday, we saw that it is apparently not so easy to find common understanding of priorities in areas. We saw that the decadal service in astrophysics and astronomy and also in planetary science revealed a set of priorities which are apparently not coordinated between Europe and the US, which revealed or results into complications in implementing resulting science missions. As we speak, our scientists, NASA's and ESA scientists, are meeting in California to find a roadmap. It's not a crisis meeting. They are meeting regularly, and it is a close cooperation since many years, so I do not want to give the impression that it is a crisis situation. But they are meeting today and yesterday to find, let's say, a solution of this situation. In Earth science, which is important for Europe, and we have also seen that there is a number of global endeavors in place. We in ESA were happy to see that the budget requests in 2011, 2012, as well as the NASA Authorization Act 2010, put quite an emphasis on space and on Earth observation and Earth science. But there we are afraid that the current or the ongoing appropriation process may particularly target this area. So there's a threat on the horizon in this area as well. And in space exploration, where we all agree that it will be a global endeavor and in a wide international cooperation, we are lacking a common political vision. We may have instruments and processes underway to find technical and scenarios and concepts, but we have not a political vision in place which really brings the potential partners on one way of thinking. And when I see yesterday the presentations in different panels on the scenarios and roadmaps in space, I wish to see a little bit more where international contributions could play a role in those kind of scenarios. Admittedly, I almost got the impression that those kind of scenarios and roadmaps describe a domestic program and not a program which is designed towards a global undertaking. ESA is obviously ready, and now I concentrate more on the exploration area, to contribute to the development of a global exploration program that is flexible enough to accommodate individual, bilateral and multilateral missions. And we see 3 success factors to achieve that, and this is on this slide, my only one, where we believe that these 3 elements are important to arrive at a program which can be really cooperative and shared by a global community. The first bullet is already accepted by everybody in the room and understood by the US, that the ISS partnership should be the nucleus of a cooperation program in exploration, and that the ISS can be a platform for preparing such an exploration endeavor, not only in a technical way that we prepare technologies and operational means, but we believe it could also be a platform to experiment or to get experience with wider cooperation in space. While the partnership in the International Space Station program should be, as I said, the nucleus also for a partnership in exploration, we believe that such a partnership should not be exclusive. It must be opened to become really global. We are ready to work with other ISS partners to study under which conditions new partners could consolidate our common goals. The second element, a common space transportation policy. I believe when we talk about cooperation in space exploration, we have to see also into cooperation into space transportation, because a space transportation infrastructure will be the core element of any space exploration program. And when we talk about a cooperative program in space exploration, we have by deduction also to talk about a cooperation in the space transportation infrastructure. This does not mean that we want to build jointly launchers or integrate all our programs, but I think we should start with a common identification of the needs we have in terms of space exploration, including necessary redundancies. We should find out what are the existing capabilities of the partners, because all the potential partners, ESA for instance, but Japan as well, others, have space transportation means. What is on the table? How can we make use of that in such a scenario? We should see what is necessary to modify in this set of existing capacities, what needs to be developed newly. The identification of necessary and then to agree when we define and when we identify what has to be modified or what has to be developed as a new element, to assign roles to the different partners. The joint identification of standard interfaces that should allow us to make our different elements interoperable is only one first step in this direction, but an important one. Finally, I addressed it already. It is good to have a fora that think about technical concepts, about scenarios, about roadmaps, but this will not be sufficient to get the political push behind a real global space exploration program. We believe that it is essential to establish a high-level political forum that is able to generate a common political vision and to, by that, to generate a political push that really supports and brings us behind such an endeavor. Especially in Europe, where we have so many countries and so many politicians who are happy to find excuses not to contribute to such a program, it will be important to bring a common story and a common initiative behind it. This requires political leadership, which in ESA's view, given the substance of the US program, can only be the US partner. And we are looking forward to that. We are certainly accepting a US leadership in this domain and would more than welcome it in this area. Finally, let me go back to this very core topic of this session, partnership that matters. I believe that a partnership that matters is not only defined by a long tradition of a partnership and by a number of projects we have, but finally by the readiness to accept interdependency. Without interdependency, we will not really be able to exploit our resources to the maximum, to share costs, which means that we make an exercise affordable to all the partners, and we will not really enter a cooperation that matters. So my final plea is that we should sit together and make our partnership in future even more mattering than it does already today. Thank you.
Thank you, Andreas. And our final panelist is Dr. Bill Smith. He's currently the president of the Association of Universities for Research in Astronomy, AURA. Many of you here know it as the organization that oversees the Space Telescope Science Institute activities, which worries both in our world about the JWST, science community utilization and operation Space Telescope, as well as the Hubble Space Telescope. In addition, they cover a number of ground-based observatories in here in the U.S. and South America, and have partnerships with the National Science Foundation. Prior to that, Bill was a staff on the staff of the House Science Committee, and he rose to staff director near the end of his tenure. He has a PhD and has conducted research in fields of atmospheric chemistry and ozone depletion and global warming. Bill?
Okay. Thanks. Thank you. Oh, here it is. Okay. Thanks. So I think it's logical to round out this panel with talking about the partnership between NASA and the science community. I wanted to do this by talking about a particular partnership that led to the establishment of the Space Telescope Science Institute in Baltimore, and I'm going to use a little bit of historical context to tell this story. There was always, I think, in NASA's view, the possibility or the very high priority placed upon having a large orbiting space telescope. From day one, that was something that they wanted to do. In order to make that successful, they felt, rightfully so, that they had to engage the science community in this endeavor. But it was a part of the science community that hadn't grown up around NASA. It had been in place for over 400 years, since the time of Galileo. They were hardwired in terms of their behavior patterns and their expectations. So this was a very difficult job from the outset for NASA to construct in a useful way and engage with this community. So my talk is, how did they pull this off? So first, let's look at what a partnership means, and I turn to my primary source of all information, Wikipedia, and it talks about the mutual dependencies that Andreas Teichmann mentioned, as you might expect, but it also goes on to describe in a much more useful way than you would get out of a normal dictionary the difficulties in any partnership, whether it's a commercial enterprise, interagency, or intergovernmental. You encounter these same issues that you have to negotiate. The negotiations are never easy, and they were never easy with the science community either. So at the point in time that we start our story, there were a few perceptions that were resident in the science community that I would say were impediments to proceeding with this partnership. First, many in the science community were very suspicious of NASA and the competence of NASA scientists. NASA scientists felt the academics were ivory tower. So there was a lot of bad attitude to go around. There was some truth in these, but neither of them were really true 100%. There was also the fact that this community was very used to dealing with the National Science Foundation. A National Science Foundation manages the community in a very, very different way, a hands-off way. And many in my community found the NASA management approach to be jarring. It took a lot of getting used to. And finally, certainly at the outset, NASA was viewed as an engineering agency, not really a science agency. So how did NASA overcome these impediments? Well, I start the story with my personal hero, James Webb, who was, I think, the very first very strong science advocate within NASA. And if you're guessing I'm going to come back to James Webb, yes, you're right, I will, a very different James Webb. So if you look at what he did, he was the second NASA administrator. It was very impressive in terms of his vision. He understood from the outset that mounting a program like Apollo or a space telescope was a very, very difficult political job, and you had to bring together many parts of the community and sort of mold them into a common vision. And you simply couldn't dictate this from the top. So there actually is a very interesting discussion. Actually, it was an argument between Jim Webb and President Kennedy on this date in 1962. You can actually dial in and listen to these transcripts if you'd like. But in this particular one, Kennedy was really urging NASA, and Jim Webb in particular, to take on Apollo as the primary agency goal to fully dedicate itself to this purpose. And so he baited him with this question: don't you think this is the primary goal of NASA? Guess what he said? He said no. That once, and in fact it's a very interesting back and forth. And he reasoned that once you had developed space transportation systems and space technologies, that you were opening up a science frontier that was at least as important as the human spaceflight program. So this goes on for a long time, and it's really well worth reading. But again, you end up understanding that Jim Webb was a very, very powerful figure with very strong convictions, and science was a part of this. So he undertook the question, how do you best engage the science community? And again, the first task was dealing with the community that would be using the space telescope. So in 1965, he commissioned a study by his friend Norman F. Ramsey, who was a physicist at Harvard, and he asked him the question, how do you put together a partnership between NASA and the community? The Ramsey Committee came out with something which I think was very surprising for its time. And the recommendations were that you really vest responsibility for managing science in a nonprofit consortium of universities. He even had a name for it. Well, this consortium never actually came about, but some of the consortia, including my own, that were being formed at this time very much resembled what he had in mind. This came as unhappy news, I think, to NASA at the time. And one of the, I've just through ways of quotation tried to capture some of the responses. This one by Homer Newell, who was running the science program at the time, and he felt that establishing this nonprofit consortium was really going to be competitive with the other NASA centers, with other universities, and felt that this was very counterproductive. So he did not want to proceed through this route, and he proposed to Webb as an alternative that they establish this advisory committee, the NASA Missions Board, and it's sort of cut off there. But what I've said is that the relations with the science community begin to sour, which is really an understatement. Nobody liked this idea. It simply didn't seem to be working, and this persisted for nearly a decade before the view within NASA began to change. And so my next data point is in 1975, and here there were a few individuals within NASA that I think really made a difference. One of them was Noel Hinners, and this is a quote from him. And in thinking about this dormant recommendation, he really felt that it had merit. Not only was it a way to he said pacify, but to engage the ground-based astronomy community, but in fact, this kind of group could act as a very strong advocate and amplify the NASA mission. He was very, very prescient in his view. So he wanted another look at this, and he commissioned his own study. And this one, let me illustrate some other community views here. Of course, the NASA astronomers at the time really did not agree with NOAA for the most part. They really felt, again, that this institute would be competitive with other elements of the community. They favored a very distributed system of science centers. For their part, the community itself was somewhat divided. There were a lot of different views on this. Just in looking at the history of this, in my view, the top tier institutions were very strongly convinced that such an institute was the only way to make the Space Telescope work. But there were many others who did not think that, and in particular, it seemed to them, and this is just in the nature of astronomers at that time and even today, that this was a drift towards big science. They didn't want a national laboratory for astronomy. And so this, by no means was this view, uniform throughout the community. There were a lot of different views. So again, Noel Henners began to consider, how to move forward on this, and he commissioned a report by a person by the name of Donald Hornig, who had been a science advisor under the Johnson administration. But more importantly, he was the world's preeminent expert in explosives at the time, and a minor historical note, it was his finger that pushed the button that exploded the first atomic weapon in the Manhattan Project. So his report was the second most explosive thing that I think he did in his career, and it led to this report, which you can see is sort of yellowed and dog-eared, and we have it preserved under glass in Baltimore. It is our Bible on how to make these partnerships work. And it's called the Institutional Arrangements for the Space Telescope. And so just extracting the main recommendations from this report, it does recommend very strongly that an institute be established, but it was very, very, I think, insightful in recognizing that this was a complicated partnership, and this institute would have to really partner with the rest of the astronomy community. That was a main job of the institute, and going the other way, partner with NASA. It was a three-way partnership. So this is something that we have really taken seriously as our mandate then and today. So this certainly had a happy ending in the establishment of the Space Telescope Science Institute, and we certainly benefited by a high-performance, cutting-edge instrument, but also a very dedicated staff that has tried very hard to make this partnership work. So some of the results are really far-reaching, not only for the purpose of the Space Telescope Science Institute, but this also led to the Chandra Science Institute and also the Spitzer Science Institute. So NASA now has a lot of experience in going this route. So the returns are really quite impressive by any measure. My people in Baltimore are very good at counting things. So I look at some of the data that they amass in terms of metrics. Hubble Space Telescope has produced over 9,000 rough-read publications. So if you do the math, that's more than one per day. And more recently, it's 2 per day. So it's increasing in its productivity, a very impressive telescope, and enabled by the staff at the Space Telescope Science Institute. There are 340,000 citations, so these are 40 per day. I don't know how we got counting daily things, but I think it's really interesting to look at it that way. There are more than 40 countries around the world that, in our last cycle that had principal investigators that got time, and there were more than 5,000 unique investigators. So you might note that that number is a pretty large fraction of the entire astronomy community, not only within the U.S. but worldwide. So continuing beyond the science, it was community building. They have looked at how many young researchers are supported through a very generous guest observer program that NASA has funded, and it's very impressive, 300 FTE years worth of young researcher salary, and a large number of dollars to support postdocs and graduate students, and 500 PhD theses. So we take this mandate to train the next generation of astronomers very seriously. And the other institutes are doing the same thing. So we also obviously are very appealing to the public. One interesting thing that we have looked at is what sort of impressions, and I'll explain what those are, occurred right at the point of the fifth servicing mission and then afterwards. An impression is a news story multiplied by the circulation. So as you can see, right at the point that the servicing mission happened, there was a spike, but more impressive was that the science really generated a huge public interest following this. So the 30-year partnership, we're coming up on our 30th anniversary of this partnership, is multidimensional. It grew over time. We have worked very hard, as has NASA, to make this work. And we have enhanced the return of Hubble, but in a more far-reaching way, I think that through this partnership, this was very instrumental in bringing the astronomy community into the era of big science. These were astronomers used to having 1 or 2 night observing runs on ground-based telescopes. Now they're working in a much different forum. And many of the programs that Kathy Turner mentioned, where you are looking at the cosmic frontiers, that requires not only this partnership between DOE and NASA, but between astronomers and high-energy physicists. And I think through programs like Hubble Space Telescope, they have learned how to do this. They have learned how to work in this way. As an example, you mentioned dark energy camera. The astronomy community has to give up a very, very large number of dark nights to make this work, but they see the science as worthwhile. So it's a sacrifice that they have bought into. So let's then talk about the other James Webb Space Telescope. You recall that I said that there were 5,000 individual investigators or unique investigators on Hubble. They are thinking about the James Webb Space Telescope as well. There are 4 or 5 or a number of very important missions to the astronomy community science themes that really are the subject or the objective of the James Webb Space Telescope, including the detection of planets, the formation of galaxies, cosmology, and you see it here. But if we look at the trend in the proposals that we are getting over time for HST, they match and they map on to the science objectives for James Webb very well. These 5,000 astronomers are anticipating having this telescope. They're working towards it. They see this as a continuum. So obviously, from our standpoint, that James Webb and that James Webb do match up. This is a continuum. And this is a partnership that has mattered a great deal in the past, and we hope that it will in the future.
Okay, I thank you all. Jim has given me a little bit of an extension, so we'll take some questions at this point. In the back of the room, Marcia.
Hi, I'm Marcia Smith with SpacePolicyOnline.com. It was a great panel. I have questions for everybody, but since I can only ask one, I'd like to ask Kathy to talk more about the AMS, Alpha Magnetic Spectrometer Partnership, and how that evolved, because as I understand it, there was a scientist, Sam Ting, who got together an international group of people to build it, but he did it through DOE, and then DOE had a partnership with NASA, and I'm not quite sure what happens once it's up on orbit, but it seems like a rather unique partnership arrangement. And did it work? Is it something that's a model for the future?
Is this on, or do I have to?
Yeah.
It's on? Okay. I think all of our partnerships with the different agencies are kind of unique, and it all builds out of, how the science community puts it together and what the different agencies are interested in. I haven't been part of AMS from the beginning, so I don't know if I know the whole history of it, but yes, Professor Sam Ting of MIT put together or led a group of scientists to build a scientific collaboration to build a space instrument to measure cosmic particles, search for dark matter, search for antimatter, etc., and work with I guess NASA to find out how he could get this launched. Sam Ting is a high-energy physicist. He worked at CERN for years. He worked in the U.S. He's an MIT professor. We have funded him for years, and he came to us with his science program, and so we funded his part of his research. And he had worked out with NASA how to. This is my understanding. So how to get this launched. So it was DOE and NASA. I mean, it's a different type of partnership. It's not where we're both together building the thing and launching it. Instead, he has an international collaboration with, even including China and Taiwan, building the instrument, and then NASA doing all the space services and space qualification and going to launch it and operate it on the space station. So it's a partnership in that way with doing distinct parts of it. But this is I think, close to $1 billion instrument that has its cost over the years if you add up all the different contributions. And it's kind of a unique thing. There was a prototype of it sent on a space shuttle a number of years ago, and that worked really well, and they've been analyzing data from that, and we expect this one to get a lot of exciting data too, and to be real physics experiment on the space station.
Okay.
This is really to you, Joe. You're sorry.
I'm not a panelist, please.
No, you're not an economist. You're in a country which has a huge amount of experience in diplomacy and partnerships. What have you learned in Sweden that could be useful to the rest of us?
I'm really not qualified to answer that. I'm going to pass on that one. Thank you.
Landis Markley at NASA Goddard. The question is, the Space Telescope Institute has James Webb coming. Do Chandra and Spitzer also have follow-on missions? And if not, what happens to them when those telescopes get decommissioned?
Well, I think that they certainly will. I mean, we're looking, the community is always looking towards bigger, better things and follow-ons. I think that this past decade survey really was challenged with its budget outlook, and so you don't see anything obvious in there as the far-term follow-ons, but obviously multi-wavelength astronomy is where the best science comes. And so I'm sure they will have follow-on missions in the future.
Andreas, isn't there not an ESA mission that the same community is supporting now that is going to do some of the pick up a little bit where Chandra has left off?
Well, we have a so-called Cosmic Vision program, which for a long period prioritizes and defines the mission we want to do. I'm not aware specifically whether there's a mission in this area, but it is something which we should also coordinate between the US and Europe to find out where we can match our resources in the most intelligent way.
I believe you find there, at least when we did our study and looked at the follow-on, that was the conclusion we came to in the committee, and the team actually agreed with that.
Yeah, I'll just say, I think at this point in time, the U.S. has gotten used to doing its decadal surveys. ESA has done its strategizing, its strategy exercises. At some point, those have to be joined. When we start talking about the very, very expensive missions in the future, you have to join not only the agencies, but the communities to develop, a set of priorities that doesn't give us a hiccup when we get right to the table and try to actually sign the check.
Perhaps you beyond the Western European frame.
Yes.
Over here, Jim.
This is for Charles Baker. I just wonder if it isn't worth mentioning that there was a 10-year partnership between USA and NOAA and NASA to provide help to actually save. It resulted. The input was as a result of problems in the. Actually in Bangladesh losing about 100,000 lives. So their premier, president, whatever you call him, went to our president went to NOAA, went to NASA, NASA went to USA, developed one 10-year partnership, and the project ended up putting in data processing equipment. Peripherally, France was involved, but they were pretty independent. Most of their stuff got flooded by, again, these floods. But it kind of gives you an international flavor to this, some of the humanitarian thing.
Thank you for calling that to our attention, because I'm leaving here in about 2 days to fly to Miami, Florida to our direct readout conference, which is a conference we hold once every 2 to 3 years, sponsored by NOAA, aimed at internationals who are users of NOAA data. The way the world has changed since the incident that you described with Bangladesh is the U.S. has tended to take responsibility for the countries of the Western Hemisphere, particularly in the Caribbean, Central and South America, and part of the Central Pacific Islands. And Europe has adopted a similar tutoring role, if you will, on the use of meteorological satellite data for the nations of Africa and the Middle East. And China, Japan, and India are working with the other nations of Asia. USAID at the moment is involved in one very specific way. They're partnering with the Marshall Spaceflight Center of NASA on a project called SURVEYOR, which is a Spanish acronym, although the word surveyor in Spanish is the verb to serve. And they have set up locations in Panama and in Kenya, I believe, is the Africa location. And what they're doing is training the local aggregations of folk from nearby countries and centers to make use of all types of satellite data, ranging from standard meteorological data to synthetic aperture radar imagery, which is very useful in disaster response in the tropics where there's heavy cloud cover, and even taking it to the point of public health, where you can predict the potential spread of malaria and other vector-borne diseases by analyzing the climatic conditions on the ground with satellite data. So yes, USAID has been a very valuable partner. I might note they're also very active in the Group on Earth Observations, which is one of the nations that one of the international organizations that both NOAA and NASA are partnered with.
Can I make one more comment? My understanding is that some of the equipment in Bangladesh is still working, and they are using it, especially the geosynchronous, acquiring data from that Japanese geosynchronous satellite.
Correct, although the preferred way of getting the data out in most of the rest of the world, apart from the Western Hemisphere, is through direct broadcast using communication satellites and terminals that cost only $1,700 each and have a little tiny antenna that would fit on this table are being used to pull down data in areas where there is no internet, there is no money to buy a big meteorological antenna, and the cause continues.
One of the earliest cooperative endeavors between the U.S. and Europe was the Iue Satellite, which lasted, I don't know, 15 to 20 years. It was a geosynchronous satellite that the U.S. operated for 2/3 of the time, and the Europeans operated for the other 8 hours. It was very successful.
Yes. Okay. With that, I'd like to thank all the panelists one more time for outstanding discussion.